Frequency modulation is another method of communication that is more difficult to visualize, but builds on our understanding of carrier waves, signal waves that we got from amplitude modulation. Let's have a look. In frequency modulation, we have a signal wave like before and generate a carrier wave just like we did for AM. This time, the displacement of the signal wave changes the frequency of the carrier wave. When the signal wave is positive, the carrier wave frequency is increased. And when the signal wave is negative, the carrier wave frequency is decreased. So the concept is quite simple. Visually, it makes sense, but drawing it is tricky. Anyway, let's have another listen to it. And that's actually all you really need to know about the physics of FM, because we're going to ignore sidebands because they look like this. If you think about it, the frequency of the carrier wave is going to get spread out by FM because the modulation changes frequency away from a single value. You also get sidebands, and each of these will get spread out too, creating a smeared out signal. Now, you don't actually need this bit on sidebands for A level. Anything about sidebands should relate to AM. Now, I do remember a question, I think, where the question was asking about FM and then it switched to sidebands, and the student was kind of meant to realize that that triggered a change over to AM as well. So be careful out there. But we've covered FM, we've covered AM, and you do need to know what the advantages are for those two. And I'll leave that as a task for you to go and have a look and see what advantages these two methods have got. What we're going to do next is we're going to look at how to transmit these signals.